Again, thank you so much for rejoining this session. We were to have it last weekend, but due to some reasons, we didn't manage to have the session. But I'm glad that you've again joined this session so that we can go through subnetting, which is one of the topics that we all struggle with as network engineers. And it's a very important topic that you need to understand as a network engineer. So today we are glad to have Evelyn again to take us through the subnetting session so that we are able to go back to the basics of subnetting. And this is just our first session of the year. We will be having more sessions. So I hope all of us will stay tuned in for the upcoming sessions, just so that we are able to share the knowledge with other engineers and empower each other through such kind of training. For today, we have Evelyn. Evelyn will be taking us through Subnetting 101. And Evelyn, if you are ready, you can take it up from there, unless there is any question or comment from the team before we start the session. If no comment, I hope your mics will be muted. If you have any question, you can raise up your hand and then we will give you an opportunity to ask your question. If you don't have any question, you can just remain muted so that we don't have the background noise. Thank you so much, and I invite Evelyn to take us through Subnetting 101.
Hello, everyone. How are we doing? Good morning, good afternoon, good evening from wherever you are. My name is Eve, and I'm glad to be here. I'm glad to see you all join the call again. I hope that today's session will be seamless. I hope we'll not experience the issues we had last time. I'm really hoping so. Um, I hope you guys can hear me clearly. Brian, can you kindly mute
Yes,
yourself? Thank
I've,
you so much.
I've already muted him.
Oh, thank you so much, Matt. I hope I'm audible enough. I hope there is no issues from my audio.
Yes,
Everything is perfect. Everything
I
is
can
perfect.
confirm everything is okay so far.
Okay, thank you. So in case we have any, in case I'm breaking, kindly let me know. But I don't think today we're gonna be experiencing that. For those that don't know me, I introduced myself last time, but I'm gonna do it again. I am Eve. I'm based in Nairobi, Kenya. I am an IT engineer at CRA. And yeah, well, I'll be taking you through subnetting. We're going to be talking about IP basic, IP addressing, um, how to subnet a network, and why subnetting came into place in the first place. Yeah. So, with that being said, I would like for us to start. I don't think there's anything more. Yeah, we will just start right away. So, in case you have any questions, kindly drop them in the chat or raise your hand, and Matt will be able to facilitate on that end. Because when I'm sharing my screen, I'll not be able to see your questions or when you raise your hand. So, if you have any questions, just drop them in the chat, please. Yeah, thank you. So, let's start our session on subnetting. So we're gonna be talking about IP addressing concepts and IP address structure, understanding the structure of an IPv4 address so that we are able to understand how to subnet. Okay, so let's get into it. So first, let's understand, why do devices need IP addresses? So this is an IPv4 session. So when I'm saying IP address, I'm talking about IPv4. We're gonna be talking about IPv6 later, maybe later in the year. As you've heard Matt has said that we'll have more sessions coming, You'll get to meet other engineers in the community. Yeah. And if you've not joined the community, you can join it now.
Are we able to hear Eve from your end?
No. We lost her.
Yes, I thought it was from my end. Eve, we've lost you.
She's muted actually.
Eve, please unmute. We can see the slide, but we are not able to hear you.
No, I think she has internet issue.
Okay, let's give her 1-2 minutes to just reconnect
So
so that we can continue with the session. As we wait for her, guys, what is your experience with subnetting? Are you struggling with it, or nowadays you just use the calculator and we go ahead, the subnetting calculator on Google or ChatGPT? Anyone can share the experience with subnetting as we continue to wait for Eve.
Martin,
Yes, Aaron.
how are you?
I'm good.
Good
I'm good.
afternoon,
Thank you.
everyone. So, for me, it depends on the situation. So, if I'm
Yes.
in a quick, I need something quick, I just use the calculator and just to confirm the ranges and what. But I think it's just nice, second nature. When you look at the subnet mask, you can tell the prefix length. It's just that one, it's just like pretty easy. But sometimes for the ranges, I need to be able to just get in the subnet calculator quickly to confirm that and move on.
Yes, I agree with that. Because many times we actually in rush. You've been asked, I need a subnet. And the quickest way you can think of it is just to get the calculator. And sometimes it's actually just on top of your mind. You are required, someone tells you, I need two IPs, this one I can just use /31, I can use /30, I can use /27. You know how many usable IPs are needed, you know the network address, you know the broadcast, and then you are able to quickly respond to such requests. Thank you, Aaron. Anyone else with a different experience on subnetting?
Martin, yes, I have experience about the subnetting.
Yes, Adele.
Basically, subnetting, which we are using to divide a big network to the small different networks, and
Y-
there are some different classes: class A, B, C, D, and E. And most of the time, we are using only three classes: class A, class B, and class C.
Yes, I agree with that.
Yes.
Anyone who still
And
uses
IP is specific unique address of the device. For example, my name is Adil, and for example, there is any device, and this device want to communicate to other device. There should be some specific name or specific IP which belongs to different subnetting and different subnet, and then they will communicate to each other through that IP.
that's true. Thank you, Adil, for the addition. Anyone
Thank you.
else? Anyone who is still using the pen and a paper to do the binary conversion and do all those calculations? Especially for the beginners, how is your experience with subnetting? So this knowledge
Yeah.
cuts across. Yes, yes, Ken. Someone was speaking. Was it Ken? Ken? Or anyone else can unmute and just share the experience of subnetting, where they are struggling, if they have met some difficulties, so that we are able to address all those difficulties during this session.
So, good afternoon. One of
Good
the
afternoon.
difficulty I'm experiencing in subnetting is the VLSM. So, that particular aspect of subnetting is really giving me tough time.
Yes, actually, we'll be discussing about VLSM, the variable length subnetting, which actually we use it more often than the FLSM. So I hope by the end of the session, you will be able to understand it better and be able to apply it when you are requested to at your place of work.
All right, thank you.
Thank you.
Hi, Martin and team.
Hi, Bitok, how are you?
I'm doing good. So a question,
Yes,
some few days ago, I had 2.2 points.
yes,
I'd put it on a /30, and on the other side, it was a /24.
yes.
So if you ping the point to point, it was going, but it was picking some losses.
Yes.
So when I aligned, the losses were clear. I don't know if this is a rule of thumb or.
Anyone who can respond to that, or anyone who has experienced a similar issue? Maybe Theo,
What issue? Can they come again?
Theo, you can come again with your issue.
So I had 2 point-to-point links. I've configured on one side as a /30 and on the other side as a /24. So when you do a continuous ping, I was picking some losses, but when I aligned them to be all /30, the losses cleared. I don't know if you guys have ever experienced this.
The one side was which
Was
subnet?
it by mistake or you were trying and doing try and error? So an
I'm
interesting
cheating.
question.
Could there be a possibility that some packets were sent in one direction, others were sent in the correct direction? Such that the ones that were sent in the correct direction, they were being replied to, and the others were dropping. Could there be a possibility of that?
Maybe.
David, please mute. Who is Muna in the call?
Martin, you said it's a point to point.
Yes,
Yeah,
it's a
point to
point to
point.
point.
But the other side with /24 now in its routing table, it has I think it can route to very other locations. Assuming now it has another point to point in another direction.
In the other direction,
Ignoring
yeah. Actually, that's why I'm.
the one.
Yes, yes, because maybe by any chance the longest match was picking another prefix towards a given direction at some point, and then we are sending some packets towards the correct point to point, and then sometime we are sending them towards the other direction, and then we get some packet drops.
So in my opinion, I think the issue was definitely caused on the side, which is the bigger /24.
And Theo, what was your RCA?
I had to blame the link.
No. But by correcting the IPs, you've
Because
been
actually,
able to.
yeah, I've been able, but it took me long. I didn't expect something like that.
Or it took you long to realize that
It
the
took me
packet
long
drops are
to
caused
realize
by.
that the other side is /24, the other side is a /30.
So it was a
Because you are learning
configuration
everything
mistake.
is yeah.
Okay, that I think that's why Aaron was asking whether you were just testing out of curiosity
No,
or.
I was not testing.
How was it even possible for that link to come up?
We need the person who configured that thing for this session as well.
I doubt. I don't know whether we can have a link that is different. What do you call subnets to communicate.
Try simulate this because it was between
That is the one to test.
and Cisco.
Pardon?
I'm saying it was a Cisco router. The slash 24 was on the Cisco side.
Okay, but though you are breaking.
Can you hear me now?
Yes, sometimes there is some breaking.
I'm saying the slash 24 was on the Cisco side, and then the slash 30 was on the Huawei side.
Hey, I will try this. Yeah.
Try simulate. It's just that I have not had time to try simulate.
Okay, at what percentage were you able to receive the packets?
So actually, maybe if like for 1,000,
yeah,
I could lose about almost 100. And then now the issue was the BGP was actually, it could come up, go down.
Oh, okay. I will try. So the protocols were BGP?
BGP, yeah, BGP.
All right. Okay.
Someone is not understanding. Please tell us what you are not understanding so that we get you clearly. Who is Vibe? What are you not understanding so that we are able to clarify? Anyone else with a subnetting comment? Anything to add? I'm still trying to contact Eve. She's still yet to join the meeting. But we hope we are closing.
So Martin?
Yes, Aaron.
In 2019,
yes,
I was studying for CCNA, okay?
Yes.
So I was trying to, I was trying to make sure I can subnet off head in less than a minute because of the time constraint. So now when I got good, I was now trying to validate. I practiced, then I tried to validate answers on the calculator online.
Yes.
I don't know if it's the common one that I still use up to now, but I got a wrong answer from a calculator.
Which calculator?
The subnet calculator online on Google. I swear. It was in 2019. So I was in a very big shock because I'd gotten so good in subnetting, and I saw the answer was not matching. For most of the things were okay. So I saw the answers were not matching. I thought I was done was wrong. I checked again. There's the Google subnet calculator was wrong.
Yeah, I think that's why sometimes we insist on going back to the principles because, again, if you don't understand it from the basic principles, you may not be able to tell that the calculator or ChatGPT has given you a wrong answer. So that's why
I said doubting myself. I'm like,
yeah, when you are able to go back to the basics, you understand the calculations. When even these tools, the ChatGPT, the AI tools, when they give you wrong answers, you are able to easily tell that you've gotten it wrong, and then you are able to correct or maybe do the manual calculations. That was a good pickup. Yeah, these tools sometimes they will give you wrong answers, but you as the engineer, you need to be able to tell which one is correct, which one is wrong. And even for IPv6, we are also doing subnetting. It's not just in IPv4. So you also need to go ahead and practice subnetting in IPv6, which may be even more complicated than the IPv4 subnetting due to the length of that prefix. Anyone else? Anyone else? If you'll be joining in a few minutes. The floor is still open for just open discussion or open comments on subnetting or any issue you feel you want to comment. Yes, David.
Hi, Matt. Hi, everyone.
Hey to you.
Yeah, Martin. I just want to seek some guidance, or even know if there's someone who's experienced a situation whereby a question has all wrong answers. What do you do in such a situation? You've been asked to submit, and then there is no correct answer. It's an exam. What do you do?
A question with all wrong answers, but you have to give the correct answer. Okay, for
Yeah,
exam
and
purpose, there Aaron, what will you do if you
Yeah, it's possible sometimes.
Yeah, it's possible. It's possible.
Which exam was it?
Well, it wasn't a real exam. I have to be honest. It was one of this online what do you call it? The online testing sites. You know.
Martin,
that makes sense.
A lot of contents,
Yes.
sometimes if it's not well moderated, you get to see those issues. And the reason I ask which exams is that sometimes you're able to report. For instance, like at least when you're doing some Pearson tests like Cisco exam,
Yes.
at the end of the exam, you can give some comments and remarks or feedback about it. And they will be able to find out. And also, like when you're reading a book, for example, of course, you get to find some mistakes, and then there's always a way to report those errors and what. That's why they publish some it's called errata, something like that. So I was recently studying a course for a service provider course. It's on Cisco U platform, and then it was, I think, about LDP. I was having a discussion with one of us, I met from the group. So we saw something which was contrary to the RFC in the book, in the course content, and I logged the case and it was resolved. The RFC, it was, I was saying, it was about, I think, LDP sessions. Those guys said, I think the book, Cisco book said, it's only 2 stages or something, either 2 or 3. There was that mismatch, and I logged the complaint. So if it's a platform that you have access to report, it's easy. Now, if it's a free online page they have given for test, now you have to trust your guts. But it might be important to double check with someone else, like, guys, what's the correct answer for this? So that you're sure the correct answer is not there.
Yeah, for exam purposes, I agree with Aaron. If it's an official exam that you are taking, you definitely have to give an answer. Maybe you will choose the one that is more closer to the answer, if that happens to be the case. But if it's these online platforms, sometimes they are not standardized. Sometimes people maybe are just looking for ways to get some traffic on their site. So they will just come up with all kinds of answers to a question, and then they end up giving some wrong answers. So you can provide feedback to them, tell them this is not correct, this should be the case, and then they should be able to correct that on the site. David?
It's okay. I'll share, because this looks like a real exam. It was a screenshot, so I'll share that once Evelyn is done, so that we can all of us have a discussion around it and maybe agree. I mean, do you choose the second most correct answer, or what do you do? Because you have to give an answer.
Yes. For the exam, if it's an exam, you definitely have to give an answer, and maybe that is the question that will save you we will give you an extra point to be above 60, the pass mark. So you can't risk leaving it empty. You need to give an answer to the question. And sometimes some exams may not even allow you to submit without giving answers to all the questions. So definitely you have to give an answer. So if it was my case, I'll give the one that looks like the answer. But okay, I believe we have Evelyn back. Evelyn, confirm that you are able to continue with the session. Sorry for the disconnection again.
Hello, Matt.
Yes,
Can you
hi.
hear me?
Yes, we are able to hear you clearly.
Oh, I apologize for the inconvenience. My net went down, but I've just had it fixed. So I'm sorry for that. I don't even know where you guys lost me. So can you
Slide one.
kindly
It was just on slide 1. When you are sharing the
slide?
screen, we were not able to get you, so you can just start afresh.
Okay, no problem. Can you please give me a few minutes. Let's start at 2:40, please.
240. Okay. Let's continue with our discussion then as you...
Yeah, Matt, I shared something with you. Maybe you can use those 4 minutes to...
You shared on the chat, or where have you shared it?
No, on WhatsApp. Apparently, I don't think I can like post something here.
Okay.
This man is watching some football.
I've muted him. I'll just reshare. I think I can just reshare on the group platform.
Yeah, on the chat. Huh?
So that Aaron can help us come up with the correct answer quickly.
Yeah.
I've forwarded it on the group chat. Aaron, a company applies for Class C IP address. Now 14 hosts means that you should be having 16 IP addresses, right?
That's correct, Martin.
8 branches. Yeah, I don't think there is a correct answer on that, on the options provided.
Yeah. So in this situation, what do you oh, Martin, is this one of those trick questions? Huh?
Yes, David, just come again.
Where they give you 8 branches, then they also give you. I'm saying, is this one of those trick questions where you have 8 branches? Because I don't think that information is just academic, maybe. But if the largest branch has 14 hosts, then I think you start subnetting from, the largest branch. Then from there you go to the second largest.
No, but you haven't been given those information, so I will assume this is kind of FLSM kind of question, because VLSM they will give you the exact number of different hosts in those 8 branches.
Yeah.
So I assume
True,
this is
but
an FLSM question.
but since they have said that the largest branch has you should have at least 14 hosts.
Yes.
Then you'd assume that the remaining 7 branches would have less hosts.
Yes, yes.
So if you're doing VLSM, then you begin with the 14 hosts.
With the 14 hosts, yes.
Which would give you 16 addresses, and then you have 14 usable addresses.
Yes. I
So
agree.
this should essentially be a /28.
Yes, the first branch, the biggest one with these 14 hosts, we will give them /28.
Yes, /28.
Yes.
Yeah. So there's no correct answer on this one. So anyway, I hope I don't find that situation in an exam room.
I think I think the correct approach should be to learn how to handle that situation if you find it, because there is probability, as much as it's low, you may found such a situation, and yeah, we hope, of course, we hope we don't find such situation, especially in an exam where you've spent time preparing and then you have to answer questions that don't have the correct answers.
Hello, Matt. Can
Yes.
I come in now?
Yes, please take it
Yeah,
from there.
sure.
Okay, thank you so much. Just to add on to what you guys were talking about, I think if that was my case and I've had such a question, I think I would go with FLSM, because they've said 8 branches. That should be like the key, like should help you to be able like to tackle the question. So I would go with FLSM, even if they've said the largest branch should have 14 hosts.
Yes, I agree with that also. That will be my take on the same.
Okay, so now that I'm back, hopefully that I will not experience the same issue again, but it's been fixed now. So I know that we'll not have network issues again, or my network will not go down. So we start from the beginning, right?
Yes.
Okay, good. So should we start from why devices need IP addresses, or?
I prefer you just start from slide 1 because there are new members who've joined us. So let's just start from slide 1 and then we continue.
Oh, okay, no problem. That's okay. So for our new members, thank you for joining the call. Thank you for taking the time to be here. So this session is about subnetting. We're going to be talking about how to subnet, or how to divide a network into small networks or into small subnets. Now, before we
Sorry,
can, hello.
hello. Sorry to interrupt. Brother Martin,
Yes.
uh, can you? Is it possible if it can be recorded, please? This session.
Yes, the session is being recorded.
Okay.
Then
Thank you.
please, for the new members, if you have a question, please raise up your hand or send the question on the chat so that we don't interrupt Evelyn when she's in the middle of the presentation. Okay, Evelyn, you can continue.
Okay, no problem. So We're gonna be talking about subnetting, yeah? So understanding how to divide a network into small subnetworks. That's why it's called subnetting. But before we can get into that, I want us to, talk about IP addressing, understanding the IPv4 structure, and also understanding the prefix length and how to determine the network portion and the network address of an IP. That is the IP structure, right? So then we'll talk about advanced variable length subnets. This is when we have different departments or different departments that have different users, and we want to allocate each an IP block. But before we can get into the calculations of that, before we can even get into subnetting, I just want us to lay basic foundation. This is important because later on when we're doing our subnetting, it will be easier to understand, it will be easier to follow through. So let's get into the basics of it. IP basics, right? IP addressing, how devices are assigned IPs. Yeah. So now, um, first is to first is to talk about why devices need IP addresses. And I've said this before, our IP addresses uniquely identify a device in a network. So in a network, there is no device that has the same IP address. It's like its own address, like a house address, right? So no device has the same IP address. And this helps communication at layer 3. At layer 3, we have end-to-end communication. You want a device, let's say in this particular network, let's say network A and network B to be able to communicate, right? That is end-to-end communication. So the IP addresses, they help to identify a device in a network. And we're going to be talking about IP address structure. Let's first understand the IP address structure. First, an IPv4 address. So this is an IPv4 address session. Let me just put it out right there so that when I talk about IP address, IPv4, you have it in mind, we are talking about IPv4. Later, we might have an IPv6 session. I believe Matt already stated that we'll have more sessions to come. So an IPv4 address structure. An IPv4 consists of 32 binary bits, which are displayed as 4 decimal octets. Now, for example, when we have 192.168.1.1, this is represented in 4 decimal octets. And each octet has 8 bits. Now, 8 times 4, for the 4 octets that we have 32 binary bits. That is a full IPv4 address. Now, what helps us to know or to determine the network portion and the host portion? Remember, our IPv4 address, the structure of it, it's divided into two, the network portion and the host portion. And the subnet mask is what helps us to determine the boundary between the two. And the network portion, these are the bits that uniquely identify the network which the IP belongs to. And in most cases, it's not in most cases, but in all cases, yeah, it's used to enable routing between different networks. We're going to get into that, so just follow along. Now, for our host portion, the host bits, they uniquely identify this specific device within a network. Now, for example, your PC, the IP that is on your PC, let's say if you check the IP address on your PC, that is you'll see a host address. Now, when we talk about subnet mask, in most cases you find that our subnet mask is denoted in prefix length. When we say a /24 network, the 24 is what guides us to know our boundary, or it helps us to know the difference between our network portion and our host portion, right? So now, let's say, for example, we have, again, a /24 network. I will pull my notepad. So for example, let's say we have this IP address on my notepad. We have 192.168.10.0/24. Now, for us to be able to define the boundary, for us to be able to know what is the network portion and the host portion, the prefix length, which in this case is our subnet mask, it's the one that helps us to know that the first 24 bits of this IPv4 address, the first 24 bits, that is our network portion. Then the last 8 bits, remember our IPv4 address is 32 in binary bits, yeah? So the last 8 bits is our host portion. And in this case, I'm highlighting this. I'm highlighting the first, okay, I'm highlighting the first 3 octets. Remember that I've said each octet, I don't know what's going on. Remember that each octet has 8 bits. Now, in this case, our first 3 octets, which cover 24 bits, that is our network portion. Then the last 8 octets, with the last 8 bits, sorry, the last octet now is our host portion. The /24 is what helps us to define that boundary. Now let's talk about the difference, the importance of subnet mask. We've said that it helps us define boundaries between the network portion and the host portion. Then we have it helps us, or it helps the routers to know where to send a packet. Remember that our routers send packets based on the destination IP address. So the subnet mask is what will guide the router to know where to send the packet, right? Or which interface to use to send the packet. When you look at the routing table, you'll see that the routing table shows different paths where we can send our packet to. Now, for side annotation, we're going to talk about side annotation later in the session. So just follow along. Now, we've talked about the subnet mask. I've been raving about the subnet mask. And in most cases, we don't usually, when we talk about the subnet mask, or if I'm trying to tell someone of a particular IP address, I will say the prefix length, which is much easier. I will say the prefix length is an easier method used to identify a subnet mask address. Now, which in most cases, it's written in slash notation. So when I say a /24 network, I'm trying to say that the first 24 bits, that is our subnet mask, right? It helps us to know the network portion of that IPv4 address. Now, how do we determine a network address? Let's say, for example, you have a host IPv4 address and you have the subnet mask. You want to determine where this particular host IPv4 address belongs to, or which network it belongs to. Again, our subnet mask is usually what determines the network address, but we have a process we call logical ANDing. And in logical ANDing, it helps us to compare the binary bits of a host IPv4 address and the binary bits of a subnet mask. Now, let me go back to my previous slide, this one, the prefix length slide, right? Here at the bottom, I expanded this /24 network in binary representation, which shows that the 24 bits, the first 24 bits are all ones, and the last 8 bits are all zeros. So we can say that our network portion is all ones and our host portion is all zeros. Now, if we're trying to determine the network address of an IP, we have a host IPv4 address. Later, we're going to be talking about the different IPv4 addresses that we have within a network. So let's just, follow. So now, if we have our subnet mask and we expand it in binary representation, and we have our host IPv4 address and expand it in binary representation like we have here, so the ANDing process is you compare the host bits. Let's say we have 1 and 1, one host bit of one bit of a host bit and one bit of a subnet mask. If we compare the two, we're gonna get 1. Any other combination, it will result in 0. That is the logical ANDing process. And this helps us to be able to determine a network address. I think recently we had this conversation in our WhatsApp group where we're trying to determine if the host IPv4 address was a network address or a host just a normal host IPv4 address. So the process of determining that is logical ANDing. So let's look into the types of IPv4 addresses that we have within a network. This is very important. So just follow along so that later you are able, when you're doing the subnetting, you'll be able to know what is the network address, what is the broadcast address, and what is the host address. These are the type of IPv4 addresses we have within a network. And there are differences. The differences between these addresses. So for our network address, this uniquely identifies a network, right? It identifies the network of that IP address. Then we have our broadcast address. In my next subtopic, where I'm going to be talking about network communication, I'm going to be mentioning the essence of the broadcast address. It's going to make sense just in a few minutes. Then we have a host address. Our host address is that IP address that has been uniquely assigned to your device, be it your PC or your phone. If you're using your PC or your phone right now, that's IP address that is on your PC. That is your host address, right? So now, when we talk about the types of communication mode we have within a network, we have unicast communication or unicast transmission, where, let's say, for example, it's one-to-one communication, where we have, let's say, PC A trying to communicate with PC B. That is a unicast communication. Then for multicast communication, and we usually term it as one-to-many. And I gave an example of assuming in a department we have 15 devices or 10 devices. This is just a scenario. We have 10 devices within that department. And I want to communicate with only 5 devices. So for that communication to happen, you're going to put these devices in a group. Yeah, assuming that we are putting them in a group, let's call them group A. That becomes a multicast group, right? I want to communicate with only those 5 devices. So that is, I will send a message to only those. I will send a message that will be broadcasted to only these 5 devices. So that is multicast communication, one-to-many. Then broadcast communication is that communication where I want to communicate with all the devices within a department. Again, this department that we have, our 15 devices or our 10 devices, let's say 15 devices, and I want to communicate with all of them. So I will use my broadcast I will send a message to my broadcast address. Then everyone within that room or within every device that is within that department will get that message. So that is the essence of our broadcast address, right? And in most cases, we do not assign our network address or our broadcast address to any device. Do you have a question? There's a beeping. I don't know. Let me check.
Yes, I saw someone was raising their hand. Kirogi, do you have a question? Any question from the team? Yes, Patrick.
Thanks, Martin. Now, I don't know, is the screen being shared or they have not yet shared anything on the screen? I don't seem to see anything shared.
The screen is shared by Evelyn.
Oh, I'm not able to see it. Maybe let me log out and log in.
Okay. Guys, are you able to see the screen?
Thank you.
Just confirm that you've been able to see the screen.
Yes, I can confirm.
Yes, thank you. I believe the screen is visible. Any question
Okay.
so far? Someone was raising their hand before we continue with the next part. Okay, we can continue. I believe questions will
Yeah.
come in later.
Yes, they will. I believe they will come in later. So if anyone has a question, kindly just drop it in the chat. Martin will be able to see it and call me to attend to it. So now we've already determined or we've already discussed the type of IP addresses that we have within a network and the type of network communication that we have. I hope I'm audible enough. Matt, can you confirm that?
Yes, you are audible enough. We
You're
are
okay.
able to
You're
hear
okay.
you.
Okay, perfect. Thank you so much. Now, let's talk about types of IPv4 addresses that we have. We have two main types of IPv4 address. Our public IP addresses and our private IPv4 addresses. What are the difference? Our public IP addresses, they are unique and can be routed globally. That means they can be routed in the internet, right? But our private IPv4 addresses, these are blocks that we use mostly internally within our organizations. We assign to our internal host. We cannot route them globally, right? And later, I'm going to be showing or we're going to review the private IPv4 addresses range that we have so that you're able to know when you see an IP address, you're able to know is this a public IP address or is this a private IPv4 address? So our private IPv4 addresses, we just use them internally within a network. Now, if you want, let's say, if we want to communicate on the internet and we are using our private IPv4 address, we have to translate that private IPv4 address to our public IPv4 address. And we do that through NATing, that is network address translation. But today we're not going to be going deeper into NAT. NAT is also another topic that is, broad on its own. So just have it in mind for you to communicate on the internet using your private IPv4 address. We have to translate it to our public IPv4 addresses. And in most cases, NATing happens at the edge. We configure NAT on the edge router. It can be on the edge router or our edge firewall. So let's look into private IPv4 address range. We have the class A, the class B, class C, which we're gonna be talking about in the next slide. Now for our class A, range is 10.0.0.0 to 10, which is a /8 to 10.255.255.255. Now for our class B, it's 172.16.0.0/12 to 172.31.255.255. Now for our class C, it's 192.168.0.0/16. I believe our class C is usually the most used address block. Everyone, I believe so many, especially in small networks, the class C is utilized the most. And this is the range that we have for our private IPv4 addresses. Now, anything outside of this, it automatically becomes a public IPv4 address. This is the range for our private IPv4 address. So you can take note. Then the legacy classful addressing, as I've mentioned, we had class A, class B, class C. I've also not put here class D and class E. The class D is the multicast, and the class E is for experimenting, but we're not going to look into that right now. So the class A, the class B, class C. Now, a /8 network, it means that the first octet is the network portion. Then the last 3 octets is the host portion. So that automatically means that a class A network has so many usable IP addresses. They are used for large networks. But again, why is it legacy classful addressing? Because before would only subnet, will only use a class A or a class B or a class C. Now imagine that you're working, let's say for example, you're working with a department that only requires 32 IPs. Now imagine you've been given a class C network, which gives you 254 usable hosts, and we're gonna get into that later when we do our subnetting calculations. Imagine having to work with that. You'd waste so many IPs. So with legacy classful addressing, we were using either you'd get a block that satisfies your needs, or again you'd get a block that you're wasting so many IPs. So, and because we already know that our IPv4 address space, there's been exhaustion of that, right? So that's why IPv6 was introduced, so that we can surface IPv4 addressing. So now legacy classful addressing was, it's no longer in use, right? And with CIDR notation, CIDR notations means classless interdomain routing, which came so that we can avoid wastage of IPs. You can only work with IPs that you need, right? So, for example, if you have a class A, let's say you have a 10.0.0/8 network, but you only want a network, or you only want a point-to-point link. Now you can use 10.10, the 10, let's say the 0/30. You have the flexibility when it comes to prefix notation or when it comes to prefix length. So that's why CIDR notation was introduced, to reduce IP wastage, for flexible notation, efficient allocation, because now again, you are only allowed to allocate, or you can only work with a network that um, you can allocate only the IPs that you need, or you can allocate, just a good number, because again, you have to also put scalability in mind when it comes to network design, right? So that's why CIDR notation was introduced, and also to have, or to aggregate routing, to have smaller routing tables, and this improved network performance. We're going to look into that. The concept of smaller routing tables, it's in our next slide when we are talking about subnetting, why subnetting was introduced. So do we have any questions? And up to there, are we good? Are we following? Are we confident? Do you have any questions? Because now I want to talk about subnetting. We're going to get into subnetting now. Are we good?
Yes, I believe we are good so far.
I believe. Okay.
So let's give them 1 minute. If someone has a question, they can unmute and ask. Guys, any question from you? Any comment or clarification that you need? Yes, Okungo. You can unmute and proceed to ask your question. See, you've raised your hand.
Can you hear me?
Yes, we can hear you clearly.
Okay, recently there's been this confusion about like class A, class B, class C network because the slide you just passed, class A is /8, class B is /16, and class C is /4. But I noticed when you were writing it out, class A/8, class B/12, class C/16. So it's been confusing for me. What exactly is the correct address?
Is
Yes,
this what you're talking about, right?
yes.
So actually, this is the range for class for the different classes. Class A. So class A was a /8. I'm sorry, guys. Give me a minute. I'm sorry about that. So back to what we were talking about. I believe this is the range, the original range for class A, class B, class C. For class A being a /8, class B being a /12, class C. Matt, I believe this is the range, right? The original range.
Okay.
Guys,
Okay.
you
Do we
can.
have any additional questions?
No, not a question per se, but mine was just some addition to add on what you said. Like, as per the RFC, that is the
Yeah.
correct range. So you can, if she needs some more clarification, you can read that RFC. I've posted it on the chat. Actually, that's one RFC which I think everyone now knows, right? At least.
Thank you so much for clarifying that. Thank you. Um, I don't know who asked the question, but is it clear now?
It's not very clear, but I think I'll read up on that, what you posted on the chat.
Okay.
Okay, so if I may, yeah. Okay, Matt, go ahead, please.
Yes, I believe those are the range, as Eve and Aaron has said. As per the RFC, those are the ranges for the private IP addresses. But again, the link has been posted on the chat. You can refer to the link. And if there are any further questions, you are free to ask even during the session, or you can ask them in the WhatsApp group.
Okay, thank you.
Okay, thank you so much for your question. Now, let's get into subnetting. Why subnetting came into place? Now, remember with classful addressing, we were working with big, like big broadcast domains. What is a broadcast domain, right? Um, how would I explain this? So, for example, let's say a broadcast domain is our network, right? Where if a broadcast message has been sent, each and every person within that network will receive that message. Now, if let's say you have a huge broadcast domain, a huge network, right? And again, for example, I've put an example of app. Our app requests, let's say a device is trying to find the MAC address of another device. It knows its IP, but it's trying to locate or it's trying to find the MAC address of that specific device. So it will send an app request. So it's like, hey, who is 192.160.1.2, for example? And it's like, I want to know your MAC address. Can you send me your MAC address? That message is broadcasted to all the devices within that network, right? And if you have a huge network, each and everyone will receive that message and process it, right? So now our switches propagate broadcasts out of all the interfaces except the interface that it received. We know that, right? That's how switches work. Now, for our routers, they do not forward broadcast messages. They do not forward broadcast packets. The router will check and say, oh, this is a broadcast. It will drop the message. Now imagine having to receive each and every time, let's say there's an app request or there's also a DHCP discover message, because also a DHCP discover message, when a device is trying to find a DHCP server within a network, it sends a broadcast message, right? Which is discover broadcast message. Now, imagine the router having to like process all the broadcast packets it receives each and every time. Now, So the concept of subnetting came into place first is to reduce the broadcast domain, because now again, every time the router has to process all these packets, it affects the network performance, and also that the process of having to check, having to process those broadcasts, it's CPU intensive to the router. So now having to work with a huge broadcast domain was affecting the network performance. It was affecting network performance. So that's why, you know, it was resulted to, instead of working with a huge broadcast domain, how about we reduce the size of the networks we work with? And this is what is called subnetting, reducing the size of a broadcast domain. Let's work with small networks, right? Let us reduce network traffic within a network. Let us improve network performance. And also, to be able to implement security policies between subnets when you have small subnets, right? For example, you have VLAN 10 and VLAN 20. You can choose to say, I want VLAN 10 to talk to VLAN 20. But I don't want VLAN 20 to talk to VLAN 10. Those are security policies, right? When you configure those ACLs, those are security policies that you are laying. So subnetting, we can say subnetting reduced the number of devices affected by normal broadcast traffic. And now, just as we had mentioned, with side annotation, you are able to work with smaller networks. You're able to work with any prefix length according or based on your needs or what you're trying to achieve. Let's say you want to work with a /24 network, or you want to work with a /25 network. Side annotation made it so much easier to reduce broadcast domains, and segmentation. Now, having said that, I hope we fully understand that and why subnetting came into place. Now, we have two methods of subnetting. We have the FLSM and we have the VLSM. And the FLSM is dividing a network into small networks of equal size. That is fixed length subnet mask. So let's say, for example, you have a /24 network, but you only need to create 4 or 6 subnets of equal length or of equal size. You're gonna do FLSM because you just want them to be of equal size. You want to manage them easily, and but the thing about FLSM, it gives you limited flexibility, right? For example, let's say you have divided a network into 4 small networks, and each has, let's say, for example, this example that I've given here, we're going to calculate. So let's follow. So now you've created, let's say, from a /24 network, you've created 4 subnets, right? So each subnet has 62 hosts. Now, what if you just have a department that only needs 30 usable IPs? Now, you see that you'll have an extra, I believe, an extra 30 more that are going to go into waste. Or again, maybe later it can be used, for future scalability. In case there is growth, you can use that. But again, with FLSM, it gives you limited flexibility. With VLSM is variable length subnet mask. This is when you want to, you want to tweak or you want to subnet the network based on your needs or based on the department's needs, right? Let's say you have different departments that have different number of users. You can be able to allocate IP blocks to each department or to each subnet the number of users it needs without having to waste IPs. Now, the whole concept of subnetting is not to waste IPs, right? Mostly it's not to waste IPs. And again, now the additional benefits of network performance, security, being able to implement security policies. I want us to now go into FLSM, the calculations now. Do we have any questions? Can we get right into the calculations? Do you have any questions?
Yes,
No?
I have a question. Under what
Okay.
circumstances will you still use FLSM?
Under what circumstance?
Under what scenarios, yeah, will you prefer FLSM as much as it has its own drawbacks, but what under circumstances will
I
you
think
still?
I would, okay.
Yes, just proceed.
So I think I will use FLSM when I just want, I want to create subnets that of equal sizes. And
Yes, you
yeah,
can
I
still
think of equal sizes.
you can still use, assuming that you have only 4 networks, and these networks they need 16 IPs. You can still go ahead and use VLSM to create these subnets.
Yeah.
Yes, so
For scalability, is that so?
no, I mean even VLSM can still create networks with the same subnet mask,
Yeah.
depending on the scenario.
Yeah.
So which scenarios? I'm just trying to again go back to that question of which scenarios will be suited to use FLSM despite its drawbacks of not giving flexibility.
Well, I think I would use FLSM. As I've said, I would use FLSM. Let's say if I'm trying to create if I'm trying to create subnets that are of equal length and I'm trying to easily manage them when I want consistency. So if let's say I want 2 subnets of having the same number of users, I would use VLSM.
Okay,
Am
thank you.
I am I am I making it clear?
Yes, it's clear. I think the point of the need for the same subnet, maybe equal size subnets, and also, of course, FLSM is easy, especially when you are starting to do subnetting. And if you are also in a small network where you don't care about the misuse of IP address, you can still go ahead and use FLSM because you can have only 2 hosts. You can still go ahead and use even /28. It will still work for you. But if you are in a challenging environment, you are in a big network, then FLSM may not be an option for you. That's why later she will be discussing about VLSM. Okay, you can take us through the example for FLSM, unless there is any question from the audience. Any question from the audience before we do FLSM examples? Are we following up? Are we still together? If we can get that confirmation from the audience, thank you. Okay, Evelyn, we can continue to the example.
Thank you so much, Matt. Thank you for that clarification as well. So let's get into FLSM. So now we've talked about FLSM. We want, let's say, for example, we have this IP block. I'm going to use a /24 network now, which we're going to have changes in our last octet, which we're going to look into. Then for our VLSM, we're going to use a different class, right? A different class of IP address. Now, assuming that we want to create 4 subnets, or yeah, let's work with 4 subnets. Assuming that we want to create 4 subnets, and we want these subnets to have the same number of users. So with our /24 network, again, please follow me. With our /24 network, let me write it again here, the 0/24. Now, remember that we said with our IPv4 address, the structure of it, we have the network portion and the host portion. And we already know that the first 3 octets, which is 24 bits, is our network portion. Then the last octet, which is 8 host bits, is our host portion. Now, when it comes to subnetting, IPv4 subnetting, we do not touch the network portion. We only subnet from the host portion. So the network portion, you do not touch it. We don't touch the network portion. And in this case, our network portion is 192.168.10. This is our network portion. Remember, it's a /24 network. So it means the first 24 bits, that has already been used. So we don't touch the network portion. This is our network. Let me just write it so that you can follow. This is our network portion. Now, the .0/24. This is our host portion, and this has 8 host bits. That is where we're gonna be subnetting from. When we are doing subnetting, we play with the host portion. We don't touch the network portion. I know why I keep repeating that. It's because I've seen especially beginners having challenges, having to like determine where the change is happening. But it's always good. This is why I said the IP structure that we talked when we started the session, it was important for this part so that you know that we don't touch our network portion. Once you've been able to determine the network portion of your IP, or the IP block that you're working with, once you've been able to know this is our network network portion, and this is where the boundary is. So you'll know I'm not touching this network portion. I'm only subnetting from our host portion. Now, remember that each octet is 8 bits. Yeah, it's 8 bits. Now, these 8 bits are the ones we're going to work with, right? Now, we have 2 formulas that we use when it comes to creating subnets, and when we want to know the number of users we're going to have within a network when we're subnetting, right? So let me first start with the formulas, then we can get into the calculations. So when we are creating, in this case, we want to create 4 subnets that have the same number of users. Let's say we have subnet A, it has this number of users, subnet B, this number of users, the same number of users. So now, our first formula for creating subnets, we usually say 2 to the power of n, right? So this n, what is this n? This n means the number of host bits you're going to borrow, right? Remember, we have to borrow host bits. We have to borrow host bits to create subnets from our host portion, right? So this n for the formula for creating subnet, it says 2 to the power of n, the number of host bits that you need to borrow to be able to create the number of subnets that you want, right? Now, just follow me. Now, in this case, we have 8 host bits, right? We have 8 host bits. For the network portion, just assume it for now. Let's work with the host portion. We have 8 host bits, and with those 8 host bits, we want to borrow a number of host bits that we're gonna subnet, right? So now, if we want to create, this is a question to you guys. So if you want to create 4 subnets, how many host bits can we borrow, or how many host bits will we need to borrow to be able to create 4 subnets, having our formula in mind?
You need to borrow 4.
4?
I think it's two.
Two.
Yes. So remember that I've said that the n represents the number of host bits that we're gonna borrow to be able to create the number of subnets we want. And in this case, we want to create 4 subnets. So 2 to the power of 2, we're gonna borrow 2 host bits. This gives us 4. So we're gonna borrow 2 host bits, right? We're gonna borrow 2 host bits to be able to create 4 subnets that are of equal size. Okay? So now, when we borrow 2 host bits, we're gonna have, so now I wanna show you something. Let me expand it in binary so that I can explain. I feel like when I show it in binary, maybe I'll be able to explain it better. So this is binary representation of a /24 network. So now, okay, I believe that is 8, yeah. So this is our binary representation. Our network portion is all ones. That has already been filled. We don't need to touch it. Our host portion is all zeros. And this is where we are borrowing. Now, do we have a question? Is someone raising their hand?
Yes, David.
I think your second octet has
It has
that
more?
5 has more. It has more.
Okay. Thank you for that. Yeah, I think it's now good, right? Yeah, it's good. I believe so, yeah. Yeah, it's good. Thank you so much for that. Now, I was saying that this is a binary.
Sorry, I think it's still more.
It's still more? 1, 2, 3, 4. Okay, I think now it's good, if I'm not wrong. Yeah, right? So each octet has 8 host bits. Yeah. Yeah. Each octet has, this is, yeah, each octet has 8 host bits. Now, for our /24 network, this is the binary representation of it, right? Our network portion is all ones, our host portion is all zeros. So for our network portion, that has already been filled. We don't need to touch it, right? It means that they've already been used up, right? Now, we want to borrow 2 host bits to be able to create 4 subnets. Remember our formula, 2 to the power of n, and in this case, n is the number of host bits that we are borrowing from our host portion to create the number of subnets that we want, yeah? So now, when we borrow 2 host bits, yeah? Now, this is it. You've borrowed 2 host bits. You've taken 2 host bits from the host portion so that we can create 4 subnets that are of equal sizes. So it means we have 6 host bits, right? 6 host bits that we're gonna use for the users, that we're gonna divide between the 4 subnets to give each subnet the correct number of users, or the same size, the same number of users in each subnet. Now, we've borrowed 2 host bits. Remember, it was a /24 network. Once we've borrowed 2 host bits, this block it's no longer a /24 network. Why? Because we've borrowed 2 host bits. It means the 2 host bits that we borrowed, they've moved to the network portion. They automatically become 1, 1, 1, right? So this becomes 1, 1. Now, this is the, once we've borrowed the 2 host bits, this is what we currently have, which becomes a /26 network. So what do we mean by that? When we want to create 4 subnets of equal sizes, we are working with a /26 network. It means the first 26 bits, they've been used up. They go, they represent the network portion. Let me say it, they represent the network portion. Then we have 6 host bits that are remaining. Now, for us to be able to know how many IPs are we getting in a /26 network, right? The formula for that is 2 to the power of n minus 2. Now, follow me on this. We've said that this n, this particular n in this formula is the number of host bits that have remained. Once you borrowed, once you took 2 to create the subnets that you wanted, we had 6 that were remaining because an octet has 8 host bits. So now 2 to the power of n, which in this case is 2 to the power of 6 minus 2. 2 to the power of 6 is 64. Yeah, it's 64. Now minus 2. Why is it minus 2? I mentioned it earlier that we have to remove our network address and our broadcast address. We don't assign those to any particular user or to any device. So the network address, it will represent that network. And our broadcast address, remember, it's for our broadcast communication, right? When we want to talk to everyone within that network. So we get automatically, we have now 62 usable IPs within a /26 network, right? So now 62 usable, it means we can assign these IPs to 62 devices within that network. Now, I want us to, go into how are we going to how will we know the next network, right? Remember that now we have 192.168.10.0/26. We want to create 4 subnets. The 4 subnets have each 62 usable IPs. Now, when it comes to IPv4, yeah, we've said each octet has 8 bits. Now, and within those 8 bits, each bit has a place value, right? It has a place value of different, let me say, different weights, right? Okay, let me show you something. So if we expand this, remember we had 0 as our last octet. These zeros, they have a place value of different, I would say, different weights. And remember that I think I'd mentioned this before, or it was a prerequisite for this session. You have to understand the binary system, right? Remember, our computers only understand zeros and ones. Yeah, that's why we use the binary system, which is the base 2, right? The base 2 system. Now, for each bit within an octet, yeah, has a different place value. That is the easiest I can explain so that you don't get lost. Now, we have something that we usually call, and I think if you're new into subnetting, you've heard people say, oh, you have to find the magic number, or you have to find the magic number to know the number of bits that will increment to your next network, right? So now I want us to talk about how the magic number is calculated, or how we usually able to figure out, when I say a /26, this is the magic number for /26. Or if I'm talking about a /25 network, this is the magic number for a /25 network. We want to talk about how do we figure out this, yeah? So I've said that different bits have different place value. Now, when you start from this end, right? When you start from this end, we have 8, right? Remember that with binary system is 2. So this host bit that is at the end, you start from 0, right? Remember, it has to go from 0 to 255. And why is it 0? Let me write it so that you can see, you can follow. 0 to 255. These for the 8 host bits. Remember, it's in binary is 2 to the power of 8, which is 256. But again, it starts from 0. So when you count from 0, if you count from 0, 1, 2, 3, up until 255, you get 256, right? Because each octet has 8 host bits. So now, I've said that we have different place value. Now, when you start from this, when you start from your, is it right to left here? Assuming that we're starting from here as you're going like this. So it's right to left, yeah? So now, when you start from the least bit, right? The least number of bit, the least bit, the least significant bit, yeah, the least significant bit. In this case, it is 0 because you have to go from 0, 1, 2, 3, 4, 5, 6, 7. From 0 to 7, that is 8 host bits. That means you've already covered your octet, right? I hope we are following. I hope I'm audible enough. So now,
Yes, you are.
thank you so much. So now when we start from, I want to start from here, the least significant bit. When we start from the least significant bit, right? We remember each bit has a different place value. So when you start from 2 to the power of 0, our first bit is 0 as you're going up, right? Up until the 7, right? Because of 8 host bits. Now, 2 to the power of 0, that is 1. Yeah. Now let's go to the second now, this bit, right? So when you say 2 to the power of 1 is 2. Let's go to the next bit. Remember, each has different place value. Now, when you go 2 to the power of 2, 2 to the power of 2 now, remember this is 0, this is 1, this is 2 now, this here. This is 2. Now, 2 to the power of 2, that is 4. Okay? When we go to this bit that is here, the fourth one, right? When you go to this, it is 2 to the power of 3. 2 to the power of 3 is 8, right? When we go to this other bit here, when we go to this fifth bit here, which is 2 to the power of 4, 2 to the power of 4 is 16. Now, when we go to this other one that is here, which is 0, 1, 2, 3, 4, 5, right? Now, when we go to this is 2 to the power of 5, which is 32, right? Now, we have the sixth one, right? So 2 to the power of 6, that makes it 64. And when I mean the seventh one, sorry, the seventh bit, not the sixth one, the seventh bit. Now the eighth bit, which is 2 to the power of 7, makes it 128. Now, these are the place values that we have for each host bit within an octet. Okay, so each octet, remember, we have 4 octets in an IPv4 address. Now, for each octet, each bit has a different place value, and this is the place value. So in most cases, you'll find people will say, oh, just use the magic number, but how is the magic number calculated? This is how the magic number came into place, right? So now, I hope you're following me. So now, when we have this, right, this is the place value for each bit within an octet. Remember that we borrowed 2 bits. We borrowed 2 host bits, and they went into the network portion for a /26 network. Now, if here, let me go back here. This is the binary representation here for a /26 network. Now, if this /20, this 25th, let me call it 25th, let me not call it /25, let me call it the 25th bit of this IPv4 address, right? Remember that here, the place value for this is 128, right? Because each bit has its own value. So the place value for this 25th bit is 128. The place value for this 26 bit of this IPv4 address is 64, right? I've expanded this. So if, let's say, for example, you choose to take this and map it here to see the place value for each host bit, it will guide you. Now, the /26 network, we've said that the place value for this is 64 bits. Yeah, that is the weight for this. It's like saying this is the weight for a this is the weight for a 26th bit of an IPv4 address. Okay, so now every time, yeah, for a /26 network, this becomes your boundary, right? You will always know, like, every time I'm working with a /26 network, it needs to go up with, or the increment of that /26 network is 64 bits. Okay, so now if, let's say, you are working with a /27 network, it means that if it was a /27 network, then our increment, our if it was a /27 network, assuming that this is our 27th bit, yeah, this here, assuming it was a /27 network, this is our 27th bit, our place value, or the weight that specific bit in the 27th place holds the weight of 32 bits. Yeah, every time you go up and you're working with a /27 network, it goes up with 32 bits. I hope it's clear up until there. Do we have any questions? Do you need any clarification? Are you following? Okay, I believe everyone is following. Am I audible?
We are
Okay,
following.
awesome.
Everything is clear.
I'm not able to see screens. Thank you. Thank you for each and everyone that is indicating. Good. Now that we've been able to determine that, let us calculate our Okay, thank you so much, Matt. So now that we are following and we've been able to determine the weight of our this is where the term, your magic number, came from. So when you say, oh, I'm working with a /26 network, so I'll be able to say, okay, the magic number for /26 network is 64. Yeah, so this is where the term, or this is where the analogy of magic number came from. So now we have 192.168.10.0/26. Remember, it's no longer a /24 network. We borrowed 2 host bits, making it a /26 network. Now, this first IP, it becomes your first subnet. Okay, that is where it's starting. It's like saying this is where we start. We start from .0, then we go up with 64 bits. Then we go up, you add another 64 bit. So as you keep adding, it has to reach 255. And I said, I explained why it's 255, right? 0 to 255, which makes it 256, because it's 2 to the power of 8, which gives you 256 IPs for that octet. Yeah, so each octet, that's why when we're talking about the subnet mask, when we're talking about the subnet mask, let's say, for example, for a /24 network, we say it's 255. Do we have a question? Is someone raising their hand? I'm not able to see.
Yes, Nathan. Nathan was raising his hand. Nathan Kibet, do you have a question?
Sorry, it was a mistake, I think.
Okay, that's okay.
Oh,
Okay,
okay, no
proceed.
problem. Okay. So now, for this /26 network, I've actually forgotten what I was talking about. So for this /26 network, right? So now, I've said that we'll start from 0. Oh, I was explaining the concept of each octet has 256 IPs, and I've already shown why we have 256. Remember, it's 0 to 255. And for your subnet mask, we usually say 255.255.255, let's say for a /24 network, .0, right? So it means that your first octet is filled because it has to go from 0 to 255. So once it is filled, that means you can't touch it. You go to the second octet where we have 255 again. It has already been filled. You can't touch it. You go to the third octet. It is 255. It means that has already been filled. And that's why when we're talking about a /24 network, we say 255.255.255.0. It means the first 24 bits, your network portion has already been filled. So if you are to subnet, you only touch your host portion, which is already 0. But now in this case, we want to fill that 0. We want to create subnets, 4 subnets, so that we can fill that 0 it can go from 0 to 255, so that we can say this octet has already been filled. We've already been able to divide it equally. Okay, so now this /26 is our first subnet. For our second subnet, remember, I've said that it goes up. Our magic number for /26 is 64. Yeah? So it goes up by 64 bits. So this becomes 192.168.10. Now, another thing to mention, because we are working with our last octet, our prefix length is what guides us, and I mentioned this before, it's what guides us to know that this is where we're gonna be seeing changes. Okay, so I said we are not touching the network portion. So do you see now that 192.168.10 is constant? It's not changing because initially that side had already been filled. So now the last octet, where we borrowed our 2 host bits to be able to create 4 subnets, that is where your changes start coming into effect. That's where we're going to be seeing changes. Our last octet, again, because we are dealing with a /26 network, the 26th bit is in the last octet. I'm just trying to make it more clear so that anytime you're doing your subnetting, it will not throw you off. You will not start to wonder, okay, where are the changes? Is it in the 3rd octet? Is it in the 4th octet? No. Once you know this is where my network portion is, this is the boundary. So once I start going into the, going into the left side, now the right side, because you're going from here, assuming this is right, you're going like this to the left, yeah? So once you start going into the host portion, that is where your changes are going to be happening. Now, we've said that it goes up by 64. So once it goes up by 64, this becomes your second subnet. Okay, now that we've already established that, who wants to tell us what is our third octet in this case? Hello? There's hello?
128.
Okay, perfect. 128. And why 128?
Because we are adding 64 at each interval.
Good. Perfect. Yeah. We're adding 64. That is the weight for our 26th bit. It means that we go up by 64 bits. Now, we've already created 3 subnets. Now we are creating our last subnet. This is 192.168.10.128 plus 64. That gives us 192. It gives us 192. Now 192/26. Now when we add, is someone asking a question? Yes. So
Yes,
Nathan
yes.
is asking, oh, sorry, Matt, do you want to go ahead?
Yes, the question is, does it mean 192.168 then .64, for example, will be our network address?
Yes, Nathan, and we're gonna be talking about that just right now. Hold that thought. I just wanted us to be able, to find our subnets. Then we're gonna be talking about the network address, how to determine the network address. We're gonna be talking about that in the next couple of minutes. Now, for our last subnet, we have 192.168.10.192. So when we add 64, that will be 256, right? So which becomes, remember, it's 0 to 255. So it will be 192.168.10.255. Now, do we all see that we've now filled our last octet? We went from 0 and we've arrived at 255. So every time you're subnetting, be it FLSM, be it VLSM, you always want to see where your changes will take place. We're going to look into VLSM after FLSM, okay? So now we've been able to create 4 subnets that are of equal sizes. It means that the number of users within each of these subnet has the same number of users, okay? And we were able to determine that for our /26 network. So a /26 network can only hold 62 usable IPs. Okay, so now let's find our network address. Let's find our network address for each subnet. So now when it comes to the network address is usually the first IP within that network. That first IP, that is your network address. That is the one that helps you to identify the network. And in this case, for example, for our first subnet, 192.168.10.0, that automatically becomes your network address for the first subnet. Now, we have our broadcast address. We want to find the range, or we want to know the range of this network, the first network, right? We want to know the range. And when I mean by the range is we want to know where we will start to assign the IP address, the usable IP addresses, and where we will get to our broadcast address, right? So now let me, my laptop is about to off. Yeah, nice. So now we've said that our first IP address within a network is our network address. Now let's determine, so it means that your first, let's talk about the first usable. So our first usable IP address, the easiest way of calculating your first usable IP address, you just take your network address plus 1. So that gives you your first usable IP address. So in this case, it will be 192.168.10.1. Usable IP address. Now, let's determine our broadcast address. And the reason as to why I'm not going straight into our last usable IP address, I want us to be able to determine our broadcast address so that when we create, when we try to find our last usable IP address, it will be easier. So our last usable IP address, you know, there are two ways you can go about this. Yeah, there are two ways you can go about this. So the first method is, we already established that for our /26 network, it goes up by 64 bits. Yeah. So it means that the next network will land in the 64th bit. And we say that our broadcast address is that address that is the last one within that network, right? So if our next network, or if our next, yes, our next network falls under 64, then our broadcast address will be 63, because again, it is the last IP address within that network. So our broadcast address will be 192.168.10.63. So this is our broadcast address. A broadcast address for this first subnet. Okay, I hope we are following. Now, our last usable. So usable means that this is the last IP we can give to any device within this network. Yeah, we cannot assign our broadcast address to any device. So our last usable IP address, you take your broadcast address, you take your broadcast address minus 1. It is the IP address that comes before your broadcast address. That is your last usable. And in this case, our last usable, yeah, it is 192.168.10.62. That is your last usable IP address. Now, remember when we were calculating the number of users we can get within this network, right? We say that we have our first, we have our network address we don't assign to anyone. We have our broadcast address we don't assign to anyone. We have 62 usable IP addresses. Now, have I been able to prove that we have 62 usable IP addresses? Because remember, our first usable IP address here is 1. Our last usable IP address is 62. So that makes it 62 usable IP addresses within the /26 network for this particular network that we are working with, this first network that we are working with. So, do we have any questions? Do we understand? Are we good on this? Good. I can see your reactions now. Perfect. Thank you so much to everyone that is, confirming. Now, let's leave the second subnet. Let us find the network address, the first usable IP address, the last usable IP address, the broadcast address. For this, the third subnet, before we can go into VLSM. I understand that it's the weekend. I don't want to take so much of your time, and also I don't want to overload you with so much information. So I want us to look into this. Then if we have any questions concerning FLSM, we can take a look at that. Then we can go straight into VLSM. Now, for our third subnet, this is our third subnet. Yeah. So again, our first IP within that network is our network address. So in this case, 192.160.10.128, that is our network address. That is the address that let us know that it helps us to identify this network. So when we're talking about a network, I will say, oh, I'm working with a 192.160.10.128/26 network. That is how I will put it. Or if I'm trying to explain to someone the network that I'm working with, yeah? So now our first usable IP address automatically becomes 192.168.10.129, right? Remember I say that our first usable IP address is our network address plus 1. So that becomes our first usable IP. Now, for our broadcast address, yeah, for our broadcast address, remember that 128, when it goes up with 64 bits, it becomes 192. So it means that 192 is your next network, yeah? And we said our broadcast address is that network, is that IP that comes before the next network, right? It's like our boundary. So our broadcast address is that IP before the next network. So in this case, it becomes 192.168.10.191. That is our broadcast address in this case. Yeah. So for our last usable IP address within this .128 network, someone is unmuted. Do you have a question?
Yes, just correct the broadcast address to 191 again, as you said. The broadcast address.
191, yes, 191,
Yes.
not 192, sorry. Thank you so
Okay.
much for that, Matt. So for our last usable IP address within this network, this third subnet that we created, it is our broadcast address minus 1. Do you have a question? Is someone unmuted? Okay. So our last usable IP address is 192.168.10.190.190. That is our last usable IP address. IP address. It means that this is the last IP address we can assign to any device within this particular network. So this is, in a nutshell, this is FLSM. That is how you go about FLSM when you want to create subnets of equal sizes. So you borrow host bits from the host portion, yeah, using our formula of 2 to the power of n, the n being the number of host bits that you're borrowing. So if we borrow one host bit, let's say if we had borrowed one host bit, we'll only be able to create 2 subnets of equal sizes. If we borrowed 2 host bits, and in this case that's what we did, we were able to create 4 subnets of equal size. So that is FLSM. Once you've been able to, hello? Someone is unmuted. Do you want to ask a question? I can't even see who's unmuted. Anyways, if you just have a question, you can drop it in the chat. Thank you. So for FLSM, if you, okay, I'm seeing a question in the chat. So Nathan is asking, does the subnet mask changes on each network address? The subnet mask. So, okay, let me calculate here. It doesn't change for each network address. Okay. So the subnet mask remains. If you're asking about the prefix length for each network is a /26 network. They are all of the same size. We borrowed 2 host bits to create 4 subnets that are of the same size. So the first subnet is a /26 network. The second subnet is a /26 network. The third subnet is a /26 network. The fourth subnet remains a /26 network. That is FLSM. The subnet mask does not change. Okay. I meant, for example, yes, that is the subnet mask for each subnet. 255, the 255, the 255, the 255.192. If I may expand on that a little bit as to how we arrived to 192. Thank you for asking that question. It has brought another topic or another subtopic we've not talked about. How did we arrive to 192, right? So now, remember that I said in this last octet, that's where we had our changes. Remember that I said that each bit within an octet has a place value. And I expanded that. Remember where I expanded 128, 64, 32, 16, 8, 4, 2, 1. And again, for, if you're having problems subnetting, always use this formula. If you want to find your magic number, just use this formula. Don't get tired of writing it. I promise it gets easier with practice. Okay, so now how did we arrive to 192 for our /26 subnet mask? Yeah, so now remember that we said this is where our 26th bit for this 32-bit IP address, the 26th bit falls under here. This is the weight for it. So it means that you filled the 128 and the 64. So when you calculate 128 plus 64, it becomes 192. So do you see that this is the decimal representation of our subnet mask, of our /26 network? Remember, 255, the 255, the 255, that is what we initially had for our /24 network. It means that has already been filled. Then we borrowed 2 bits, the 128, which falls under 25, then the 26th bit. Yeah. So when you add this becomes your subnet mask for your /26 network. 255, the 255, the 255.192. I hope I've been able to make that clear. So for our FLSM, the subnet mask does not change. I mean, like once you've been able to identify that this is a /26 network, all the subnets that you're going to create for that /26 network, they have the same subnet mask, which in this case is 255.255.255.192. Okay, so that is FLSM. Do you have any more questions?
Guys, any question on FLSM before we quickly look at VLSM? I assume silent means no question. Maybe they will ask at the end of the session, so you can start the VLSM part.
Matt, do you think we should take a small break? Maybe they can take some water before we can get into VLSM.
Yeah, we can give them 2-3 minutes to take some water and then we can continue with the session. I believe
Yes.
the remaining part should not take us a lot of time. So
Yes. I believe it should not take a lot of time because we've been able to, talk. We've been able to pour much into FLSM. So that's why I took my time with FLSM so that VLSM can, we can just brush through it. So let's take a few minutes, then we can pick from there.
for those with questions, you can send your questions on the chat as we take a short break.
Oya Leno. Oya Leno.
David, was it David who? Are you talking to us?
Hello, hello, Matt. I think we should now. I think people have had enough time to, I've
Yes.
had enough time to take tea or water, whatever it is. So let's roll for a VLSM. Then we can call it a day. So now, when it comes to VLSM, remember that I said this is variable length subnet mask. So variable, it means that we have the flexibility to, work, or we have the flexibility to create a subnet based on the number of users that we need. Yeah. So let's say, for example, um, we have 4 departments that are of different, or the 4 departments that have different number of users, and we have one IP block that we're supposed to subnet from. So it's like saying we have one IP, it's like saying we have one big block of land, then we wanna slice it to 4 different families. And these families have different number of family members. Yeah. So if let's say you have a family that has 10 10 people, or yes, 10 people, and you have another family that has, two people. Yeah. So of course, the way you divide that, it's not gonna be the same. You're gonna give the one that the largest family, you're gonna give it priority. So that is the same thing when it comes to VLSM. So with VLSM, when you have different departments, or when you have different subnets that are of different sizes, we're going to give priority, or it's best practice to start with the department that has the most number of users. So now I want us to use this block. Let's say we were working with 172.16.0.0, let's say /20 network. So we've switched it up a bit because I wanna work with the 3rd octet. We worked with the 4th octet, but now we are working with the 3rd octet, so that we can see our changes, or we can be able to understand subnetting better. Yeah. So now, assuming that we have, let's say, for example, we have 4 departments, and assuming that the first department has 1,000 users, yeah, then our second department, let's say it has 500 users, and our third department, let's say it has 200 users, and our last department, let's say it has, let's say it has 100 users. So now we have this big block, a /20 network. It means that the first 20 bits of this IP block, this is a huge IP block, because the first 20 bits, they've already covered the network portion. Okay, so the remaining 12 bits, our IPv4 address has 32 binary bits. So the remaining 12 bits, it is our host portion, and it has, this is the number of, I want to write it here so that we can follow. So if we have 12 host bits, yeah, it means that the 12 bits are used for users, or we can, we can subnet it to give it to different departments. It's just for our users. Yeah. So it's 2 to the power of 12. That gives us 4096 users. I believe it's 4096 users. Yeah. 2 to the power of 12. Now, this IP block, this /20, number of users. Yeah. I mean, number of 4096 IPs. And when you do -2, we'll have 40, 90, 94 users, right? But now in this case, we want to take this big block and we want to, like slice it. Let me use the word slicing. We want to slice it. We want to give each department a, a block. Yeah, we want to give it, we want to cut this IP block and give each department a certain IP block that has a certain number of users according to their needs. And in this case, we have for our first department, which has 1,000 users. Now, when it comes to VLSM, the way you approach it is a little bit different from how you approach FLSM. Remember, when we were doing FLSM, we were creating subnets. And we were creating subnets of equal sizes. That is FLSM. So how we approached FLSM, it was, I need to borrow this number of host bits to be able to create this number of subnets. Yeah, that is for FLSM. Now for VLSM, how we approach it is a little bit different because now we have 1,000 users. So first we have to determine how many host bits, yeah, how many host bits do we need to be able to account for 1,000 users. Yeah, so we approach it in the aspect of we are working with this number of users. So how many host bits will we need to be able to, to be able to account for them? Yeah. So now, in this case, let me name it Department A, which has 1,000 users, So now, how many host bits do we need to be able to create, how many host bits do we need to be able to account for our 1,000 users? Remember the formula that I talked about earlier when we were doing FLSM, where we said 2 to the power of n minus 2. N minus 2. Yeah, where we said n is the number of host bits that we need for the number of users that we require in this particular case. Now, when we say 2 to the, does anyone wants to give it a trial? How many host bits do we need to create 1,000 users? 10. So Nathan has said we need 10 host bits, which is very correct. We need 10 host bits. 10 host bits. This gives us 1024 IPs. When we remove the 2, the network address and the broadcast address, we get 1022 usable IPs. Now, in this case, we'll have 1,000. We'll have 1,000 users, right? And an additional of 22. 22 in this case. See, when it comes to this, it's not always that you're gonna get an exact number, right? When you have, let's say you slice in the subnet that you're working with, it's not always that you're gonna get an exact number of users that you need. You can get more, yeah? And when you get more, the better, because again, if let's say this department grows and you need an additional 20 users, you don't have to go again and, recalculate. You already have scalability in place. But again, in most cases, when you're doing IP addressing, it highly depends with the network you're working with or how much you anticipate for the network to grow. So now we had 0.0/20 network. But now we've already determined that we need 10 host bits to be able to account for our 1,000 users, or to be able to account for the number of users that we need in this department. Now, when it comes to this, we have 32 bits, right? 32 bits for the IPv4. So now when we say 32 minus 10, this gives us 22 bits. Now, these 22 bits, we've already said that 10 bits, we need them for our host portion. So the 22 bits, they are gonna be for our network portion. Okay, that is the network portion that we're gonna work with when it comes to this. So it means that for our 172.16.0.0, this becomes our slash 22. That is where it's gonna start. Remember, we are slicing, so we want to find the boundary for this. We want to find, it's like we want to find like where do we begin and where do we stop. Like this is the match like block we're gonna give to this department. Yeah. So again, I said VLSM is a bit different, but not, once you understand the concept of subnetting, it will not throw you off. Okay. So now in this case, remember that we were working with the slash 22 network now. Our slash 22 network, it falls under, or our 22nd bit, it falls under the third octet. Yeah. So let's expand this in binary so that you can see what I'm talking about. I hope this is correct. Yeah. The 0. Is this enough? Yeah. I believe this is slash 22. Let me. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, perfect. Now, remember that we'll say that this will be our slash 22 network. Yeah. So now, once it's a slash 22 network, it means that this is where the 22nd bit in this octet, this is where it falls under, right? Because it's a slash 22 network, remember. And our 22nd bit is in the third octet. Yeah, each octet has 8 bits. So this is where your changes are going to be happening. Now, we need to determine our magic number for our slash 22 network. Remember our magic number. I'm going to write it again. 128. I'm sorry, guys. Give me a few minutes. So sorry about that. Let's continue. So now, remember our magic number. Yeah, we have 128, 64, 13, 16, 8, 4, 2, 1. Oh my God. I'm back, guys. Sorry about that. So now, yes. Guys, I'm sorry. Let me.
As we wait for Eve, are we guys still following? Are we still on the same stage. How is your experience so far? Clinton, you are allowed to unmute.
Hi, Martin and team.
Hi, Clinton.
Yes, actually, the session is good. I'm following on, and I'm actually learning a lot here.
Oh, thank you. How is the experience from the others so far? Let's hear your voices as we wait for Eve to come back.
Hello, Matt. I'm back. I'm sorry, guys, about that.
It's okay. You can pick it up and continue with the session.
Okay. So we were talking about this. We're talking about our magic number, and we've already. I believe we all understand the analogy of magic number. So now, for our /22 network, we need to know like the weight that the 22nd bit carries, like the place value for it and how many bits it can increment with, right? Now, for our /22 network, remember that these two octets have already been filled. This is 16, right? So now this, when we get into the third octet, where I said this is where we're gonna have our changes, yeah? So this this is 16, 17, 18, 19, 20, 21, 22. Okay, I need to increase the, yeah, this is now what we have, right? 1, 2, 3, 4. Am I having the correct thing or have I increased? Oh, I've increased actually. So now this is 17, 18, 19, 20, 21, 22. This needs to be a 1 because it's already been filled. Yeah. So now we need to find our magic number for this bit where our 22nd bit lies or falls under. So when we expand that, remember each octet has in each octet, each bit that is within an octet has different place value. I mentioned that before. Now, here, it's assuming that it's like dot, yeah? 128, 64, 32, you know, when you expand it, right? In each place value. So 17, 18, 19, 20, 21, 22, yeah? So our magic number for our /22 network is 4, yeah? So it means that from 172.16, sorry, not 168. I'm so used to the class C network. We're working with the class B. So now 172.16 dot, now our changes are happening within the third octet. Yeah? Because that is where our 22nd bit falls under our /22 network now. So this is the 0, right? /22. I hope you're following. Now, remember that we said our broadcast address is usually the IP before our next network, right? So in this case, we want to find the range or we want to find the boundary for our first department. Remember, we are creating a subnet that fits 1,000 users. Yeah, it fits 1,000 users. Now, here we have 172.16.3. that is the IP before .4, right? This is 3. Now, this is where I find that most people have challenges understanding, is it a 0? Is it 255? Now, remember that we said that if we go from 172.16.0.0/22, we go up by 4 bits, yeah? In the place value of the /22 network, we go up by 4 bits. Then it becomes 172.16.4.0, right? So now, the last octet, it means that we have filled from 172.16.0.0. For us to be able to go to .4, it means that what was there previously has already been filled so that we can enter into the .4, right? So this becomes 255. It means it has already been filled. It means that there is users that have already filled that octet. It will not be 0. It will not be 172.16.3.0. No, it is 255. I hope I've made it clear. I hope that is very clear. So now, perfect. Thank you for your reaction. So now, our first department, for our first department, Department A, the one that had 1,000 users, that is the block that we're gonna assign it to. That is the, it's like a loaf of bread. That is the slice that we've given it to. From 172.16.0.0, which is a /22 network, and 172 to 172.16.3.255. Okay, for our first department. Now, let's go into the second department that we have, which we said has 500 users. Yeah, which has 500 users. So now remember that this is our starting point. We can no longer start here at 172.16.0.0. No, it's like we've already given that portion, right? So this is where we start. So it means that this is the block that we now have. After we've done our slicing, we are moving. Remember that we are assigning departments based on the number of users that we need. So if you've noticed, we are moving further and further into the network portion. Remember, our network, into the host portion, Our first, the block that we had initially, it was a /20 network. But since we were trying to slice for the first department, we moved further into the host portion. So the more you go into the host portion, and what do I mean by that? When you go more into the host portion, this prefix length keeps increasing. It means that your network portion becomes bigger, it gets more space. It means you're signing the network portion represent the network. You have many, like you have it's like your network. When you unify it, it's like you have one big network, yeah? So now your host portion will reduce because of the number of users you're working with, yeah? So now this is our starting point. And we have 500 users. So how many host bits do we need to be able to account for 500 users? Someone can, raise their hand and answer, or, unmute. Okay, so yes, Eunice. Thank you, Eunice. Eunice has dropped an answer in the chat. So we need 9 host bits to be able to, create a subnet that accounts for the 500 users, right? Now, again, remember that our IP address is 32 bits, right? So 32 minus 9, that gives us 23. It means that 23 bits represent or have, okay, is someone asking a question? No? Okay. So now, it means that our network portion is 23 bits and our host portion is 9 bits, yeah? So this is going to be our /23 network. Remember our boundary, we got to .4, yeah? So now 172.16.4.0/23. Why? Because we are slicing, we are getting, we are borrowing more host bits to be able to create this subnet, or to be able to account for the subnet that we are trying to create. Now, for our /23 network, yeah, for our /23 network, remember our magic number. So how many bits does it go up with, or the increment for a /23 network? So for our /23 network in this case, remember this is our magic number. We are still within the third octet, because that is where our /23 network, or no, that is where our 23rd bit falls under in the third octet. So the changes we're gonna see are still gonna be in the third octet. And remember that our magic number for our
Wait,
/20.
please, I have a question.
Okay, go ahead.
Okay, I'm sorry, I don't know if I'll draw you back, but based on the first subnet that was created, that is 172.16.0.02/22 to 172.16.3.255. Is it that we have a minimum of 0 to 3 usable hosts on that subnet? Because I'm confused.
What do you mean by 3 usable? I'm trying. Okay, so okay, is your question based? Are you trying to understand that how many users you're gonna have within that
Yes.
subnet? Okay, okay. So you know what I was explaining before. I was saying, you see, from our, you've only see the change is in the third octet, right? So from, it's like saying from 0 to .3 to 255, right? Are you following me?
Yeah, I'm following. I was
Okay.
muted.
Okay, no problem. So from now, I want you to look at it like this. Our changes are only happening in the third octet. So it's like saying from 0 to .3, then the fourth octet, it's not that there is nothing there. The fourth octet, remember our change is only happening in the third octet, where why is there change in the third octet? It means that it represents where our network portion was falling under. Then the last octet, it means that has already been occupied by users. So from 0 to .3 to 255, that range within there, that is users. We have like 1022 users, usable IPs within that range.
Hmm.
Is it
Honestly,
clear?
honestly, it's not clear. But let me see if I'm making sense from my end. So you mean from 172.16.0 to 172.16.3 will keep going up like this: 172.0.255, 172.16.1.255 to be reached 3. Is that what you mean?
Mm-hmm.
Oh,
172.0 so when you go up is 172. So it's like 172.16.0.0, right? As it goes up is 172.16.1.255. Then 172.16.2.255. It goes up. Do you get now?
yes, yes. Thank you
Okay,
very much.
perfect. Perfect. So now we are now slicing for our second department, which has 500 users. And we've already established that we need 23 network portion to be able to have only 9 host bits to account for the 500 users. Now, 2 to the power of 9 minus 2. So 2 to the power of 9, that is 512 users. Then when we do minus 2, we're going to get 510 users. Yeah, 510 users. So it means that we will even have an additional of 10 users within that subnet, right? So now, remember our magic number. We want to find our boundary. We want to know how up, or we want to know how many bits we're gonna fill from 172.16.4 to a certain number of bits that we're gonna fill to be able to account for these 510 users. Yeah. So now 172.16.4, right? The 0/23. Our magic number for the 23rd bit, right, is this. Remember, this has already been filled. Now this expansion here, the place value that I showed you, it's for this octet. The third octet, this is the first two octets have already been filled. Now we're in the third octet. Now it's this 128 is 17, 18, 19, 20, 21, 22, 23, where this second subnet falls under. So it means it will only go up by, follow me on this. Why am I saying 192? I'm so obsessed with 192. So it's 172.16.0/23. Yeah, but now we want to find our boundary. Remember, we want to know how many or we want to know the bits that have been occupied by the users for this specific subnet. I'm lost a bit. So Nathan, where are you lost? Hello Nathan, can you hear me? Can you repeat on how you arrived to .6? Okay, perfect, no problem. So how I arrived to .6. I hope you're following how we arrived to .4.0/23. I hope that makes it was clear. Okay, good, perfect. Now, how we arrived to .6. Now, remember that we want to know, like, for your /23, it's like saying, I want to know, like, how many bits do I need to increment to the next network? Because again, it's a /23 network. That is the network that we are supposed to work with to be able to accommodate our 510 users, right? And for a /23 network, we know that it goes up by 2 bits, right? It only increases by 2 bits. So when you work with the magic number here, right? Remember how I explained the magic number. So when it goes up, so that we can know our boundary for this specific subnet that is supposed to accommodate 510 users. We want to find our boundary. Okay, we want to know, like, this is the increment that we have. So that is why we arrived at .6, because when you check the place value for /23, it goes up by 2, right? So it means that this is the next network. This is the next network. But again, we want to know our boundary for where our last subnet, we want to know this is the last place. Once it goes to the next network, that is another, it's like another block. But we want to know for this block, this is the starting point and this is the ending point. Is that clear? So that's why we have .6, but we are not touching that right now. We want to know our endpoint for this second department. Okay, I think you're following. So I need to keep moving. Yes, very clear. Okay, perfect. Thank you. So now we have 172.16. Remember our broadcast, right? It is the IP before our our next network. And in this case, our change is only in the third octet. The fourth octet, that has already been filled by your users. So we want to see our change happening in the third octet. And in this case, this becomes .5 because we are working with a /23 network. I know I keep repeating myself is because I want everyone to fully understand and to follow. So that's why I'll repeat in different situations or scenarios so that we can fully grasp it. Now, in our last octet, this will not be .0. Again, it will not be .0. Why? Because we are saying that when we go up from .4, we are filling from .4. So it's like saying you go from .4 to 255, then you enter 5, then from 5 to 255, then you're entering .6. Yeah, you keep, it's like you want to fill your octets. So here it becomes 255. Now this is the subnet range for your second department that has 510 users. You see, the more we assign subnets, various subnets that we are assigning, right, the more we are eating into the host portion. And again, remember I said when we don't touch our network portion, we go further into the host portion. When we are doing subnetting, that is the same case. It's just that with VLSM, it's a bit different. You think from the perspective of the host that you're working with, yeah? So now, this has already been filled. This has already been filled. So you can't, this is another department. You've already sorted that one out. That 172.16.4.0 becomes your network address for this particular subnet. And 172.16.5.255 becomes your broadcast address for this particular subnet. Now, we want to subnet for our next department. So it means that if this has already been filled, yeah, we have no business with that. We've already filled it. It's taken. Assuming it's taken. Yeah. So now we have 172.16.6.0/23. This is now our starting point again. So when we are subnetting, we're gonna be looking at it like, oh, I'm starting from .6 for the /23 network. Yeah. So now we have for our okay, let me just write it. 16.6.0/23. Now we have our 200 users for our department C. Yeah, this is department C. Now, back to the basics again. How many host bits do we need to be able to create create a subnet that has 200 users? So we need 8 host bits, right? Because with 8 host bits, it will give us 2 to the power of 8. That is 256 minus 2. That is 254. So if let's say we go a bit lower, if we say 2 to the power of 7, it will give us 128 users. You see, that is not going to be enough. So we'll just have to work with the next bit, yeah, the next bit, which is 2 to the power of 8, which gives us 256. So it means that within this network, we're going to have an extra of 54. When we remove the network address and the broadcast address, we'll have 254. So it means that this network will have an additional of 54 IPs, because initially we only wanted 200. So another thing, you see that in as much as you will still have IPs remaining, you cannot always, it's not always that you're gonna get, a fixed number of IPs or a fixed number of users that you want. You will still have some flexibility, yeah? And you still have scalability as well, because if let's say the department grows and you need more IPs, you already have that. Yeah. So now we're gonna work with 8 host bits. So when we do 32 minus 8, 8 being the number of host bits that we need, then this becomes 24, right? It becomes 24. So now the 24, this 24 means this is our network portion. The 24 means that the first 24 bits have already been filled. Those are the network portion. So we can touch it. Yeah. So now remember our starting point is 192.16.0.0/24. It's no longer /23. The further you move into the IP block, the further you move into the host portion, it reduces, right? Your prefix length increases. So that means your network portion increases and your host portion reduces. Yeah, because you are assigning the more you are assigning the subnets, you're adding the number of users. Okay. So now in this case,
Sorry to interrupt. Should it be 16.6?
oh, .6. Yes. Thank you, Matt. Sorry about that. This is .6. Yeah. Sorry. This is our starting point. Sorry, guys. So this is .6. Yeah. So this becomes /24. It means that we are accounting for the 200 users, or in this case, let me say 254 users. Yeah. Because we found that we need 8 host bits. Now, for our 24 network, our /24 network, we are now entering into it means that our first octet, it means that the first 3 octets have already been filled. So if it means they've already been filled, it means that it goes up by only 1, right? It only goes up by only 1 because 1 is the magic number for our /24 network. Remember this magic number here. So again, 17 here, 18, 19, 20, 21, 22, 23, 24. You see here it falls under 24. The magic number for /24, it falls under 1. So it means it only goes up by 1. Yeah. So this will become the 7.0/24. Now we want to find our broadcast address for this network. Remember that our first 24 bits have already been filled. So it means if the first 24 bits have already been filled, the last 8 bits, which we're going to be using in this case for our department C, it means that the last 8 bits, it automatically becomes our host portion in this case. Yeah. And remember that when we were doing FLSM, I say that each octet goes from 0 to 255, right? Which accounts for 256. Then minus 2, the network address and the broadcast address, we have 254. Now, in this case, it means your last octet, it's already filled. Yeah, we're going to fill the last octet. We're going to fill it with the number of users that we need. So this becomes 172.16.6.255. Why? Because now your change has applied in the last octet. The 255 has already been filled because you're working with 254 users, or we are accounting for, initially it was 200, but we can't have 200 users within a subnet. It's 254, right? So that is the subnet range. It means 172.16.6.6.0 is our network address. Then 172.16.6.255 is our broadcast address. So between 172.16.6.1 to 172.16.6.254, that is the range. We're gonna assign those IPs to devices. Okay, so now this is our department C. Let me write it, department C. That is the range. Now we are in our last department, and in our last department we have 100 users. Now with 100 users, how many host bits do we need to create to be able to account for 100 users? Do you have someone that wants to try that?
Yeah, just a correction again. That 172.17, I believe it should be 172.16.
Matt, thank you so much. So this is 172.16.7.0/24. So now we want to, create, or we want to slice it a bit more to be able to, account for the 100 users. So do we have anyone that wants to try? Okay. Yes. Thank you, Benjamin. So we need 7 host bits to be able to account for the number of users in this particular department. So because when we say 2 to the power of 7, which gives us 128, right? 128 IPs, then minus 2, which gives us 126. So we're gonna get 26 usable IPs within this network. So if we need 7, host bits, it means that the network portion will be 32 minus 7, which gives us 32 minus 7, which gives us 25, right? It gives us 25. So it means that the 25 bits have been used or have been occupied as the network portion, right? So we're only going to have 7 host bits to assign to the users that we need in this case, right? So now, remember that now this is a /25 network. We are moving further into the host portion from what we initially had. So this becomes 0/25. Yeah, 172.16.7.0/25. Yes, it becomes a /25 network. You know, a /24 network. A /24 network is 254 usable IPs or 256 IPs in total. That is including the network address and the broadcast address. A /24 network is a /25 network. It's 2 /25 networks, actually. Because when you look at it, when you borrow 1 host bit, you're going to create 2 subnets that are of equal length. So it's like dividing a /24 network into 2. Because if a /24 network has 256, if you divide it into 2, it is 128, yeah? And remember our magic number, the concept of the magic number. Now, we've already stepped into the 4th octet because it's a /25 network. Once we've finished with 24, we are stepping into the 25 up until the 32nd bit, right? So for our /25 network, our magic number is 128. Yeah, it is now 128. Because it's 128 plus 64. Now this I'm expanding for our last octet. 32, 16, 8, 4, 2, 1. Yeah, this is the last octet now. And we are here. The place value for the 25th bit is 128. Yeah, so now give me a minute. Now, in this case, it means that the changes that we're gonna have, it's gonna be in the 4th octet. Remember, this is our starting point. 172.16.7.0/25. And now we've gotten into the fourth octet. The changes are going to happen in the fourth octet. And we've already stated that for a /25 network, oh my God, 172.16.7.0/25. Yeah. So now for our /25 network, we're going to go up by 128 bits in the fourth octet, because that is where our changes are going to be happening now. It means that from where we started in the beginning, right from /20, as we slice, as we give different sizes to different departments, we've been subnetting the network portion, the host portion, because we are moving further into the host portion, right? So now for this network, our starting point is 172.16.7.0/25. So it will go up by 172.16.7. Remember, it's a /25 network. So your first 3 octet, they will not change because they've already been filled. Now your changes are happening in the fourth octet, making this 128, right? Sorry, let me show you something. This is where our next network will be. So now for us to find our boundary for this is 172.16.7.127. That is our broadcast address for this particular network, which is our department C. Yeah. So now this other network here, this is another network on its own. Let me put it /25. This is another network of its own. And it means this network has 128 users. So if you wish to subnet more, maybe create point-to-point links, you'll still have enough to create that. But in this case, this is our boundary. This is the subnet range for our department D. And we've been able to create different sizes of subnets for each department based on the number of users that are required in each subnet. And with that being said, that is VLSM. So VLSM, you have this big block, and you keep eating into it. It's like saying, I want to keep slicing based on the number of users that I need in each department. Hello?
Eva,
Yes?
is it possible for us to get a copy of your sticky notes?
Okay, yeah, sure, no problem. I can copy and paste. Where should I send it? Should I send it in the WhatsApp group? Are you in the WhatsApp group?
Yeah.
Okay, no problem. I can send it there. I will just copy and paste it there. So that maybe later you can just follow. And if you have any questions, you can ask me any questions that you have. Do you have any questions? I know it's been a long session. So silence means we don't have any questions. Maybe, I know maybe someone wants to go and internalize, try it on their end, then come back and ask questions. You can drop your questions in the WhatsApp group. Link, okay, so Gilbert, okay, Matt will be able to, paste the WhatsApp link here.
Okay, I'm doing that right away. Thank you, Eve, for the amazing session. I believe We've learned a lot from the session, especially with the examples that you've given, very clear explanation, and we appreciate your effort. I know it takes time to prepare for such sessions. We are glad that you've managed to do such an amazing presentation, and we've all learned from it. And I also
Yes.
appreciate everyone. The session extended past the expected timelines, but we've been patient enough to listen in and actively participate throughout the session. If you are saying something.
No, I just, yeah, I just wanted to, wrap up my presentation. So thank you so much to everyone that joined the call, to even those that came back again after we had issues last time. Thank you so much. I hope you've learned a thing or two, and I hope that, okay, so with subnetting, practice makes perfect. Honestly, I used to struggle with subnetting. I know a few of my colleagues are on these calls and they can tell you that. So with subnetting, you just have to keep on practicing and it gets better. Yeah. Thank you so much. Thank you so much. And also a special shout out to Matt and his team for setting up this community. If you're not part of the community, kindly join our community. There's a lot to learn in that community. There's a lot of resources you can get there. You don't have to walk alone. I promise. When you're doing it with the community, it becomes so much easier. Matt, thank you so much.
Thank you again, Eve, and thanks everyone for taking your time and joining this session. We will be having many more sessions. Actually, next month on 14th, there is someone who is coming in with OSPF, which is a protocol that we use in almost all the networks. So there will be another session that will be coming in soon on OSPF, and I hope you will all be able to join and actively participate. So thank you all for joining. Unless there is any question from the team.
Martin,
Yes.
please, I want to ask where we can be practicing the. I want to ask Everly where we can be practicing the subnet marks challenges so that we get better.
Hello. So I know there's a website where you can practice subnetting. I will have to confirm that website, please. I'm not very sure. I think it's subnet.net or subnet. I'm not very sure, but I will confirm. Please let me confirm it, where you can go and just, it asks you questions on subnetting. It just sharpens your subnetting skills. I will share the link, please.
Thank you.
I also suggest if you can give a practice question on the group, on the WhatsApp group, especially for VLSM. Make it as complicated as possible so that we are able to practice and then give you feedback on the same.
Yes, I think that is a good, yeah, that is a very good idea because I do understand that this was a very long call, so it might be draining for some. Um, we'll have to do that in the group chat. Yeah, we'll have more conversations on that. Thank you.
Any AOB from anyone from the audience who wants to comment or add anything before we close the session? Anyone with AOB before we close the meeting? Okay, thank you so much, guys, for joining the session. See you again. We'll be communicating on the next session that we'll be having next month. Thank you and have a good weekend.
Thank you. Bye, Matt. Have a good weekend, guys. Bye.